So here's a video on the Algebra 2 Spring 22 practice final. Only some questions explained because some other questions come from other videos and other practice tests and stuff. So we're just going over some of the questions. Here we go. F of x equals x squared plus 5 and g of x equals x minus 3. So given the above, given that, find f of g of x. Okay, so remember how this works, guys. You take whatever's in here and you plug it into the bigger outside function. So let's actually go to my notebook here. I already have the question copied. So just to remind you, like if I told you find f of 5, what does that really mean? That means for you to plug in 5 into your f of x function, not the g of x, right? So you're going to take the 5, put it right there. 5 squared is 25 plus 5 is 30. However, we don't have f of 5. What do we have? We have f of, and instead of 5, there's g of x. So the question is, what is g of x? G of x is x minus 3. So in reality, the x minus 3 is going to get plugged into the f, right? Just the way we plugged in 5 into the f, we're going to take the g of x function, the x minus 3, and plug it into the f. So what is our f of x function? Let's scratch that out. F of x is x squared plus 5. Now, you're probably wondering, why did he put parentheses instead of x? Because we are actually going to plug in the x minus 3. The x minus 3, we're actually going to plug it in right in there. So x minus 3. And we got to work this out. We really have x minus 3 in parentheses squared. So that's really x minus 3 times x minus 3. And then we also have the plus 5 at the very end. Of course, you're going to multiply first. You're going to multiply before adding. So you got to multiply the binomial times the binomial. X times x, x squared. X times negative 3, negative 3x. Negative 3 times x, another negative 3x. And negative 3 times negative 3 is positive 9. And let's not forget about the plus 5 at the very end. Let's combine like terms. Well, the x squared can't be combined with anything, but the minus 3x and the minus 3x, that becomes minus 6x, and the 9 and 5, that becomes 14. So your answer is f of g of x equals x squared minus 6x plus 14. And that would be this answer over here, x squared minus 6x plus 14. Let's move on. On this question, we have a square root function. Actually, it doesn't even matter what kind of function it is. But yes, it's a square root. I know this is a square root function because it starts off at a point, shoots off in one direction. It's going down forever. It's going to the right forever. The a value is negative because it's shooting down instead of up. It has a shift, 1 to the left and 2 up. But then again, none of that really matters because they're not even asking us to talk about the square root function. They just want us to state the domain and the range. And again, the domain are all of your x values. Okay, so the domain are all of your x values, left and right. So does this graph exist at -1? Yes, it does. Does it exist at 0? Yes, it does. At 1? Yes, it does. 2, 3, 4, 5. It exists from this beginning point, which has the x value -1, and to the right, which means that the domain is x is greater than or equal to, greater than or equal to -1. That's your domain. Now let's talk about range. The range are your y values, 1, 2, 3, 4. Notice that the graph does not exist at 4. It doesn't exist at 3. It starts existing at the y value of 2. It also exists at 1 and at 0 and below, right? Even though it curves off, it never completely flattens out. It keeps going down and this way forever. So the range is the y values. So let's write that down. Range are the y values. And this is obviously less than or equal to that beginning point, the y value of 2. Now, it's important to know or to note the different notation that is used on the final exam. So I hope we could see which one's the correct answer, which would be this one right here. Now, it's important also to state that there's some answers that look like that, but they don't have the or equal to, so be very careful with that. That's impossible. That's not right, because we do know that the beginning point is a solid dot. So that means it's or equal to. It could equal, the x value could equal -1, and the y value could equal +2. So you need those or equal tos. Anyway, I guess let's just move on to the next question. Finding the inverse. Finding the inverse. I hope we remember how to find the inverse. Here's a question. How do you find the inverse? Switch x and y, then solve for y. Now you're thinking, okay, well here's x, but where's y? Remember, f of x is the same thing as y. If you wanted to, you could just put a big giant y right there. Anyway, we're gonna switch the y with the x. We're just gonna magically switch them. So instead of y, it's gonna say x equals, we have 3y instead of 3x squared, 3y squared minus 5. Okay, so we have switched the x and the y, and now we're going to solve for y. What does it mean to solve for y? To get y by itself on one side of the equal sign. So let's get rid of everything except this y. I am going to add 5. What do I have so far? On the left side, I have an x plus 5 equals 3y squared. What does 3y squared really mean? It means 3 times y and then the square. Actually, it means 3 times the y squared. So let's get rid of the multiplication of 3 by dividing by 3. Now what you do to one side, you have to do to the other, but you do have a binomial on the other side. So I'm just going to divide the whole thing by 3. It is possible to split the division of 3 to the x and to the 5, so it could be x over 3 and plus 5 over 3, but I'm just going to leave it like this as one fraction. And last but not least, I need to get rid of the square. So how do I get rid of the square? I'm going to square root to get rid of the square. So square root and square root. And of course, whenever you apply a square root in an equation, you're going to put a plus or minus in front of your answer. So we do have a y on this side, and we have a plus or minus square root of x plus 5 over 3. And we could put this y equals on this side, put y equals plus or minus the square root of x plus 5 over 3. And even better, so instead of just putting a y equals on this side, I am going to put the appropriate inverse notation, which is f with the little -1 power x equals. That is the good answer right there. The inverse is plus or minus the square root of the fraction x plus 5 over 3. Let's check that out. That will be this answer right here, the square root plus or minus the square root of x plus 5 over 3. So we have a cube root question, and let's go to our notebook here. There's a question. Now, if we had a square root problem, we would want perfect square numbers. I might want to make a perfect square number list like 4, 9, 16, 25, 36, 49, and so on and so on. But since this is a cube root, I would like to at least make a couple of numbers that are perfect cube numbers that I could actually use. So if I did go 1 times 1 times 1, that would be 1, and that's a perfect cube number. If I went 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27, right? 3 times 3 is 9, times 3 is 27. And then we have 4 times 4, which is 16, times 4, that's 64. 5 times 5 is 25, times 5 is 125, and so on and so on. And I think that's pretty good right there. I mean, we could always go with the, what is 6 times 6 times 6? 216 is 216. Might as well do 7 times 7 times 7. 343. And I did that with the calculator. I don't know that off the top of my head. But anyways, I have my perfect cube number list, and I could go 8 times 8 times 8, but I don't think that's going to be 640. I might as well do it. Yeah, 512 is 8 times 8 times 8, and that doesn't cut it, right? 512 is the 8 cubed. So we want, this is obviously not a perfect cube number, and we want to rewrite it with multiplication to get one of these perfect cube numbers. So what you should do with the calculator is try to divide 648 by maybe 343. That doesn't work. Maybe by 216. Let's try 216. And if you do that on the calculator the way I just did, you'll be happy to know that it ends up being 3. So I could rewrite the 648 as 216 times 3. And of course it's still times x to the 8th, right? But now we could take the cube root and split it to each of those. And we know that the cube root of 216, that's going to be 6, because 6 cubed is 216. So that's really a nice, beautiful 6. This cube root of 3, you can't really do it, so we're going to leave it as the cube root of 3. But over here, we actually need to work this out. So we need to remember that a rational exponent is the same thing as a radical, okay? And I don't know if we remember this, but let's review this right now. That when you have any base, in this case x, and it has a rational exponent, an exponent that's a fraction, so you're going to have your power over your root, okay? So the notation is your root, your base, and your power. Okay, so this is the notes that you need to know to do this last expression right here, this last cube root. You see, this is really 8 divided by 3, okay? So you would like this 8 to be divisible by 3, but it's not divisible by 3, right? 8's not divisible by 3. But what you could do is rewrite this 8 with multiplication to get a power that is divisible by 3. So this is what I'm trying to say. I could take this x to the 8th and I could rewrite it. I could rewrite it as x to the 6th times x squared. And of course, it still has this cube root on it. So let me put that cube root on it. And of course, we can now split that cube root. So you have the cube root of x to the 6th, and you'll have the cube root of x squared, which you can't really do. But we can do this guy right here. Again, power over root. So 6 divided by 3 is 2. So this really does equal x squared. So that's really an x squared. This guy right here is x squared. So what do we have left? We have the beautiful 6. Let me write it in red here. Here's my final answer. Beautiful 6. I have the beautiful x squared that I just found right here. 6x squared. And then we have what's left over inside the root. So we have the cube root of 3 and the cube root of x squared. So let's put those together. The cube root of 3x squared. Ladies and gentlemen, this is your answer. 6x squared times the cube root of 3x squared. So I believe the correct multiple choice answer was none of these are correct, because all the answers did not have the square on the inside. So please select none of these are correct for this one. We have another cube root expression that we need to simplify. So here's our problem. And again, we're dealing with cube roots, not square roots. So we should think of perfect cube numbers, like 1 times 1 times 1, like 2 times 2 times 2 gives you 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, and you know, we could stop there because none of these numbers are bigger than that, well, significantly bigger. The question is, could we rewrite 128 to be maybe 64 times something or 27 times something? Could we get a perfect cube number in here by rewriting this with multiplication? And I would start with the bigger values first. Don't start with 8. I mean, 128, it might be divisible by 8, but look, if you go for the bigger one, it's a lot better. 64, I know that 64 doubled is 128. So I could rewrite the 128, I could rewrite that as 64 times 2. And then I could split the cube root to each of those, okay? And of course, don't forget about the outside multiplication of -2. But continuing on, the cube root of 64. We know that the cube root of 64 is 4, right? Why? Because 4 times 4 times 4 is 64. So what we really have here is the negative 2 times 4, and we still have the cube root of 2 that we can't really do right now. Might as well do negative 2 times 4. That'll give us a negative 8, cube root of 2. Okay. What else? Well, obviously 9 can't be broken down to 8, so that's already simplified. But over here, 54. 54, could it be rewritten as 27 times 2? Yep, 27 times 2 is 54. So let's do exactly that, 27 times 2. And when you split the third root to each of those, you will now have the cube root of 27, which we know is 3, okay? So again, the cube root of 27, that's the nice, beautiful number 3. Don't forget about this minus 4 that's out here in the front. So it's really a minus 4 times 3. And of course, the cube root of 2, you can't do it, so we're just going to bring it down. The cube root of 2, you can't simplify it. So let's now finally multiply negative 4 times 3. That'll give us negative 12. And the cube root of 2 stays the cube root of 2. Now, what about the middle term? Let's just bring that down. It was already simplified. So we're going to take this plus 3 cube root of 9 and just rewrite it down here, plus 3 cube root of 9. So what we really have is the same 1, 2, 3 items that we need to add or subtract. But now that we have simplified, we could ask ourselves, do we have any like terms that we could actually add or subtract? And the fact is, yes, we have the cube root of 2, we have negative 8 of these, and we have negative 12 of these exact cube roots of 2. Okay, so let's combine like terms. We could combine the negative 8 cube root of 2 with the negative 12 cube root of 2. That's like saying negative 8x minus 12x. That'd be a negative 20x. But in this case, it's not a negative 20x, it's a negative 20 cube root of 2. Now, what about the leftover? You can't really add that. It's not like terms, so just bring it down. Plus 3 cube root of 9. So here's your answer. Negative 20 cube root of 2 plus 3 cube root of 9. And as you could see, that's this answer right here. On this question, we have a fraction, and we need to simplify this fraction. And of course, we do have powers, so we're going to have to use the rules of exponents. What could we do here? Well, if I had like an a to the 5th and an a to the 4th, I could just cancel 4 with 4 and I'd be done. But it's a little bit more complicated than that because we have an exponent that's a fraction. So what I would like to do is first move this denominator, the a to the positive 2/5. I'm going to move it up. So it's going to be right next to this one, a. Now, if I do move it, the exponent sign, the 2/5, is going to change to a negative 2/5. Okay, so it's gone. It's no longer on the bottom. So let me rewrite what we have right here. We have a to the 3/4, right? A to the 3/4 times a to the negative 2/5 times a to the negative 2/5. No more fraction. So rule 1 of exponents tells us that when we're multiplying two items with the same base, we could simply add the exponents. If I had x squared times x to the 3rd, the answer would be x to the 5th because 2 plus 3 is 5. But the problem here is that we have fractions instead of a nice number 2 and a nice number 3. But we do know the rule that when you're multiplying with the same base, you have to add those exponents. So the real answer, the final answer, is going to be a to a certain power. What is that power going to be? Well, I need to add the 3/4 with the negative 2/5. So let's do that. 3/4 plus negative 2/5. In order for us to add or subtract fractions, we need a common denominator. The denominator 4 and the denominator 5, the LCD will be 20. And how do you change the 4 to become 20? You multiply it by 5, which you do to the bottom, you do to the top, multiply it by 5. You get 15 up here. 15/20 is the same thing as 3/4, right? And then over here, how do you change 5 to become a 20? Well, you multiply by 4, multiply by 4, you're going to get a negative 8. And now that you have the same denominator, 20 and 20, you could actually combine 15 plus negative 8, giving you a 7. So the answer is 7 over 20. But remember, what is this answer? This is really just the answer to the combination of these exponents, or combining these exponents. The exponent 3/4 plus negative 2/5, the answer is 7/20. So the answer is A to the 7/20. That is your answer, A to the 7/20. Let's go back to the multiple choice and see. And here it is, A to the 7/20. So pick that one. Okay, let's move on. This is a pretty straightforward question. Hopefully you guys understand it right off the bat. It says, for what value or values of x is the expression undefined? So first of all, you need to remember what undefined means. How do you get a fraction to become undefined? You need to end up with 0 in the denominator, okay? So the denominator has to be 0. So you got to look at this factored form denominator. Actually, this still needs to be factored. First, factor everything, okay? And then you could split it all apart with zero product property and set them each equal to 0. So once again, you can't do anything with x. You can't do anything with x minus 6. But x squared minus 25, that is a difference of 2 squares. So you should remember that, you know what, let me write this whole thing over here. You have the x minus 6, and now this one's where it gets fun, because that one you could factor even further to x plus 5, x minus 5. I hope we remember that back from when we used to factor, when we were pros at factoring. Anyway, the numerator is still 3x, x minus 7, but who cares, because all it's asking for is for what values will this whole thing become undefined. And it's this simple. If your denominator is 0, if all of this is equal to 0, and it's all multiplying, right? This times x minus 6 times that. If it all equals 0, then you could split them up and set them each equal to 0. So that means that this first x, that could be 0. The x minus 6, that could be 0. The x plus 5, that could be 0. And the x minus 5, that could also be 0. And if you solve these, you'll have your answers that will make this expression undefined. 0 will make it undefined. Plus 6, x equaling 6 would make it undefined. Minus 5, x equaling minus 5 makes it undefined, and also plus 5, plus 5. So x equaling positive 5 also makes it undefined. So the numbers for what values would make this expression undefined: the 0, the 6, the 5, and the negative 5. Which is this one down here. That's the only one. The other ones are wrong. Okie doke. Let's move on. We have multiplication of 2 fractions here. I always recommend for you to factor anything possible first and then try to cancel things out, okay? So the only thing I could see right off the bat that I could factor is 16x squared minus 1, because that's a difference of 2 squares, right? I mean, let me give you a review. X squared minus 9. Oh, the x squared and the 9, you could do the square root of both of them. The square root of x squared is x, the square root of 9 is 3, the square root of x squared is x, square root of 9 is 3, and you could put a plus or minus in between both of those, or a minus and a plus. And that's how you factor it, right? So I hope we remember that. Let's do that to this above numerator of the second fraction. So second fraction, let's factor. The square root of 16x squared, that'll be a 4x. The square root of 1 is 1. And of course, because we have a minus, one has to be plus and one has to be minus. Anyway, the denominator, 2x minus 3, can't do anything to that. Let me just rewrite it. We have times, first fraction, 4x plus 1, can't do anything with that. Now, this numerator up here, I know I can't factor it, but I know it's looking out of order. I like to have my x first and my number second. So let me take this negative 2x and put it in front, okay? So think about that. I am going to move this negative 2x, because the minus sign does belong to the 2x, and I want to move it out here to the front. Negative 2x, and the 3 is positive. So far, I have right here a negative 2x plus 3. Let me just write it over here, negative 2x plus 3, okay? Now, I do notice that this one is a 2x minus 3, and this is the exact opposite of it, right? It's a negative 2x, that's a positive 2x. It's a positive 3, it's a negative 3. So if I factor out a negative 1, then I will have the 2x minus 3 that's down here. Once again, we move the negative 2 to the front. Here it is in the front. Now I factored out a negative 1. If I pull out a negative from here, it's going to become positive. Pull out a negative from here, it's going to become negative. So I have a negative 1 on the outside. I have 2x minus 3 on the inside. And notice that now it's ready to cancel with that guy. So we have factored everything. Now let's cancel. The 2x minus 3's cancel. The 4x plus 1's cancel. So what's left over? Negative 1 times 4x minus 1. All we have to do is distribute. So distribute that negative 1. You'll get a negative 4x plus 1 as your final answer, which is this guy. All right, let's move on. On this question, we have a fraction that's being divided by another fraction. So we need to remember that when you are dividing by a fraction, the division really changes to multiplication, and the second fraction has to flip. So when you have a fraction divided by a fraction, the division changes to multiplication, and this fraction flips, multiplied by its reciprocal, right? And the first fraction stays. So my first fraction is going to stay. My second fraction is going to flip. However, I do want to factor as I go. So my first fraction, the numerator, I have a quadratic trinomial. And I hope we remember that when you have a quadratic trinomial, to factor it, you gotta think what times what is your C value that if you combine together is your B value. And you might want to make a list like what times what is negative 20? Well, it could be like negative 1 times 20, negative 2 times 10, negative 3 doesn't work, negative 4 times 5, and that's about it. Now, which pair of numbers combines together that'll give you the middle value, positive 1? So 20 and negative 1, that's 19, that's not positive 1. 10 take away 2 is 8, that's not positive 1. 5 take away 4, that is a positive 1. When you combine the negative 4 and the 5, that'll give you a positive 1. So that's a correct combo that we want. So here is our factored form, numerator. Put an x right there, an x right there, and you pick the pair of numbers that worked, thinking what times what was C that if you combine together is B. So you put the negative 4 right here and the positive 5 right there. So this has now been factored to this. Let's do the same for the bottom one. What times what is your C value that if you combine together is your B value? So you might want to make a list. How could you get positive 4? 1 times 4 or 2 times 2? That's about it. Now, which pair of numbers combines together to give you the middle value, negative 5? Well, 2 plus 2 is 4, not negative 5. 1 plus 4 is 5, but it's not negative 5, but it is a 5 at least. So I have the right number, just the wrong sign, which means I have the right numbers, just the wrong signs. So this is the right pair of numbers, but I need to change that to a negative, change that to a negative. So on the denominator of my first fraction, I will have the factored form x, x, and the pair of numbers, which was a minus 1 and a minus 4. Now for the second fraction that I am going to flip, and as I flip it, I am going to factor. So this denominator, the 3x minus 3, I'm going to pull out the GCF of 3 as I move it to the top. So again, the denominator is going to be up on top, and I am pulling out a 3. What would be left over on the inside if I pull out a 3? Think about that. Pull out a 3 from the 3x, you're going to have an x left over. Pull out a 3 from a 3, you're going to have a 1 left over with the minus sign, right? And you could verify that. 3 times x is a 3x. 3 times negative 1 is a negative 3. Now this one is a difference of 2 squares. and I'll be able to factor it. X, and we think what times what is a negative 25 that if you add together is a middle value b, which there is no middle value. So what times what is a negative 25 that if you combine together is nothing because there is no middle value. That'll be a positive 5 and a negative 5. So we have both fractions in completely factored form. Not only that, we flip the second fraction, change that division to multiplication, and now we could cancel out any identical values up on top and on bottom. And what we have, what we're looking for are identical binomials. For example, we have the x plus 5 up here with the x plus 5 down there. So cancel that out. We also have the x minus 4 right here and the x minus 4 down there. So you could cancel that out. And we also have the x minus 1 with the x minus 1. And I just want to say it's okay to cancel above and below on the same fraction. It's even okay to cancel from down here to up here on the same fraction, on the other fraction. That's totally fine. But you never want to say, oh, I have a x minus 4 down here, or let's say x plus 5 and an x plus 5. You can't cancel those out. They're both on the bottom. That doesn't work. The only way something eliminates is if you have the identical value up on top and on bottom. Okay. Anyway, we canceled out everything we could. What's left over? A 3 up on top and an x minus 5 on the bottom. 3 up on top, x minus 5 on the bottom. There's your answer. Oh yeah, fun stuff. We are adding and subtracting fractions. Now this is not an equation, right? There is no equal sign and then something else. If you did have an equation, you could get rid of fractions by multiplying everything by the denominator of the fraction that you want to get rid of. But as we have just stated, this is not an equation, so we actually have to get a common denominator to be able to add or subtract them. Okay, so we could think of 8, 4, and 10, and also W's to get the LCD, right? So what is the LCD of 8, 4, and 10? Well, I know that I could change 4 to become 8, but I can't change 10 to become 8, right? I can't change 4 to become 10 or 8 to become 10. So my tip to you is go to the biggest value, in this case the 10, and you already thought 4 cannot be changed to 10. 4 times 2 is 8, not 10. 8 can't be changed to 10. 8 times 2 is 16, not 10. So then take that bigger value and double it. So now think 20. Okay, 20, right? 10 times 2 is 20. Could you change 4 to become 20? Yes. Could you change 8 to become 20? Nope. Okay, so now times 3. That'd be a 30. Could you change 4 to become 30? Nope. How about times 4? That'd be a 40. Could you change 4 to become 40? Yes. Could you change 8 to become 40? Yes. So we know that the LCD is 40 with a W, 40W. So I'm just going to copy the question, move it over here, and the reason why I'm moving it over here is so I could show you that I'm going to rewrite all three fractions, but with the LCD of 40W. There's a minus and a plus. Here's my 40W, 40W, 40W. How do you change the 8 to become a 40W? Well, you're going to have to multiply by 5W. And what you do to the bottom, you do to the top. So you get a 5W up here. Now, how do you change the 4W to become 40W? There's already a W there, so all you got to do is multiply by 10 times 10 times 10, and you'll get a 30 up here. And how do you change the 10W to become 40W? Well, all you got to do is multiply by 4. Multiply by 4, and that'll give you a 28. Now that we have a common denominator of 40W, you could actually add up all your fractions, put it over the answer 40W. And could I add 5W with the negative 30 and a positive 28? The answer is no. But I could, so let me just write down the 5W first. 5W. And then negative 30 plus 28. If you owe $30, you have $28, you're going to owe $2. So that's going to be a minus 2. And ladies and gentlemen, this is your answer. 5W minus 2 over that common denominator 40W, which as you can see is right here. That's why that's the correct answer. The other ones are not. So that brings us to the end of this video explaining certain questions, right? I only explained maybe 10 questions of the practice final, and there's over 35, I don't know, maybe there's a lot of questions on the practice final, so I didn't even explain half of them here. The other ones are on other videos from other lessons or from other practice tests. So I hope this helps. If you're watching this video by itself, remember there are way more questions than the ones that you just saw on this video.